I think we should go back to basics and also try to understand, how is neurofeedback implemented in the brain, as well as, how these so-called mechanisms in neurofeedback that are based on neuroplasticity, what could the mechanisms be in the brain and how they act over what period of time, how are they implemented in terms of the neural circuits, and so on. I think it's important to go to the evidence in the neuroscience literature, as well as what we know currently from neuroscience, to try to understand, how we can best leverage neurofeedback and also understand what kind of effects we can expect and how these effects might be related to cognitive and psychological function. The course will cover the basics of neurofeedback, how neurofeedback impacts leveraged by the brain to be able to control its own states, and then looking at how this control of these brain states can influence neuroplasticity and then behavior, clinical disorders, and improvement in symptoms. I think I would like to start with essentially how is EEG generated in the first place, how these electrical fields or waves that we record, how they generated, what do they actually represent in the brain. It's based on synaptic activity, but these synaptic activities are quite complex. So how do they all sum up to create these big signals that we can record? And then how those different levels of synchronization or activity across different frequency bands may be related to different cognitive or psychological states. And then going from that to seeing what potentially these kind of dysfunctions in the brain, like in brain disorders, how they are linked to the patterns that we see with the EEG, and then how we can use neurofeedback to so-called correct these patterns or reverse these patterns. The theory of QEEG also is about normalizing the EEG and so on, but there's also theories about why that would be beneficial for cognitive function in the first place. I'm essentially a cognitive neuroscientist working currently at the University of Geneva in Switzerland. I've done my PhD in London with John 𝗪𝗲𝘂𝗁 at the University of London. After that, I moved for my first postdoc to University of Western Ontario. My PhD was based on some neurofeedback research where we looked at the impact of neurofeedback on peak performance and also motor learning. Before that, I did a master's in France in neuroscience, and before that, a bachelor's in physics at Imperial College London, which is an engineering college. The course could bring these different angles, understanding neurofeedback from these different angles. The physics side, and maybe engineering side, as well as the physiology, neurophysiology, and also psychology, obviously. Recently, I've done some research in psychiatric disorders like ADHD and PTSD in collaboration with the different research institutes. The relationship between psychological cognitive function and the patterns that we see in the brain is actually very complex. It's not very easy to ascribe only one pattern, one function. Since the brain is a neural network, individual regions might also perform multiple functions. But essentially, the way it's done in neuroscience, at least currently, it's through a machine learning framework where we don't make any real assumptions about this particular pattern is this function, but we look at reverse engineering in some sense, where we look at some patterns and we know that are associated with certain disorders, and then we see, okay, which of these patterns can be used to classify certain disorders. That's more like a correlative approach. So across different disorders, you might find different patterns, and then you're asking the algorithms, machine learning algorithms, to work out which patterns are the most discriminative. And from there, you can say, okay, well, this disorder has this particular pattern that is specific to it, or a particular symptom, and so on. So that's kind of more like a mathematical framework. But then, of course, the real litmus test is to see causally whether these patterns are really involved in the dysfunctions. And in that case, you need to modulate these patterns themselves, right? So usually that's been done with brain stimulation, but of course, neurofeedback fits into that category of interventions. So I think neurofeedback is a really elegant way to test for causality. So if you find that a disorder is presenting some patterns that are, let's say, deviant based on the QEEG that was more than 2 or 3 Z-scores away, then you can try to reverse those patterns and see, okay, do the symptoms also normalize or not? And in that case, you can see, is there actually this link between the patterns and the behavior? Einstein said that things should be as simple as possible, but not simpler. So the idea is not to overcomplexify things in the first place, but to find like the right balance between where we have the most impact, but without complicating things where we do an overkill in terms of the technology or the number of sensors that are required to improve brain function. I think it's important to also have an idea of how neurofeedback might work on the neural level, since that's where it's kind of done, because we're working with neural signals. And there's a lot of background to how neuroplasticity might be implemented in the brain through the different neural networks. So different concepts like neural synchronization, how correlations between neurons can impact plasticity, as well as different brain disorders, how different functions are implemented in different anatomical regions to attention and memory and so on. So there's a lot of things that we know in neuroscience that could be useful for understanding neurofeedback and also probably for developing neurofeedback in the future. So it's about the status quo from neurofeedback, what we know about the current protocols, but as well as how we can advance in the future and innovate new protocols for neurofeedback in clinical disorders. So my course will also try to look forward to future development of neurofeedback in terms of what we currently know and what we could maybe know with more research.